Hello. Welcome back to the channel. So let's do another kind of problem. This time we are reversing the process and we're calculating a definite integral by evaluating the sigma notation formed by Riemann sums. So you remember in the last videos we converted the sigma notation into a definite integral. This time we will be evaluating a definite integral using the sigma notation that we will evaluate. So now, as you also would know, that whenever we have to calculate the integral of fx dx, we basically take this sigma notation where our I varies from 1 to n, and I'm calculating fxi delta x, right? And the xi is basically based on whether you're taking a left hand Riemann sum or a right hand Riemann sum, right? And in order to calculate the definite integral in this case, which is based from a to b, we take the limit n tending to infinity of this whole expression, right? So these were the fundamentals that we already covered in the last videos. If you still didn't get what this expression means, I would highly suggest you to first watch the previous videos in order to get the full context of this question. And we also know that in this case, since we are calculating a right endpoint Riemann sum, our xi in this case is a plus I delta x, where a is my starting point, the starting endpoint of the definite integral, the left endpoint of the definite integral, and my delta x in this case is b minus a over n, where b is the right endpoint of my definite integral. So let's evaluate this expression based on all the given information that we have. So now we know that we have to calculate definite integral of x square dx between the intervals x equals 2 to x equals 4, right? The same question that we have over there, and we have to use right endpoint Riemann sum. So let's calculate our xi and delta x first. In order to calculate xi, I know my xi is a plus I delta x and my delta x is b minus a over n. So let's calculate delta x first because we'll need delta x in our xi expression. So if I calculate this, my delta x becomes b is 4, a is 2, and n would be n. And remember, n is a constant in this case, right? So my delta x would be 2 over n, right? And now let's calculate xi based on this information. So my xi in this case would be 2 plus, since my delta x is 2 over n, my xi would be 2 plus 2I by n. So I got this, I got my delta x as well. And now based on all this information, let's denote our sigma notation. So we know that our sigma notation is sigma I goes from 1 to n fxi delta x, where my limit is n tending to infinity in this case. So let's evaluate this expression first and we'll take the limit at the end in order to simplify the calculations that we are doing right now. So let's denote our sigma notation. So now we are calculating this part only. Sigma I goes from 1 to n fxi delta x. And since my xi is 2 plus 2I by n, and remember in this case my function for which I'm calculating the area under the curve for is x square in this case, right? So my fx is x square in this case. Let me write it down on the side. So my fx is x square in this case, right? And if I'm calculating fxi, you remember when you have to calculate a function value based on a given point, you substitute that point, that x value into the function and get the y value, right? So we'll do the same. So if I am calculating fxi, it would become sigma I goes from 1 to n, fxi would become xi square, and delta x is in this case is 2 by n that I already calculated before, right? And I also know that my xi square is 2 plus 2I by n. So let's calculate that thing. So sigma notation, sigma I goes from 1 to n again. This is 2 plus 2I by n square because it's xi square, and I'm multiplying the whole expression with 2 by n. Fine. Now let's evaluate the square and open the square in order to simplify all the terms that we have, right? So now if I open the square, I have sigma I goes from 1 to n. Let me put this 2 by n on the left hand side, and then my square part, which is this, would expand to a square, which is 2 square, that is 4, plus 2ab, so 2 times 2I by n, plus b square, which is 2I by n square in this case. And if we further simplify it down, it would become 2 by n, this is 4, and this is 8I by n, and this would become 4I square by n square. And now let's multiply 2 by n with this part. So if I multiply 2 by n with this part, I'm taking sigma I goes from 1 to n. 2 by n times 4 is 8 by n. The second expression would become 16I by n square, and the third expression would become 8I square by n cube, right? And I'm calculating the sigma for the whole expression. And I know when I have the sigma notation, I can split this sigma notation on all these three parts, right? So let's do that. So basically what I'm doing right now is I'm taking sigma I goes from 1 to n of 8 by n plus sigma I goes from 1 to n of 16I by n, and I'm taking sigma I goes from 1 to n of 8I square by n cube. And now the only thing that matters in our sigma expression is this variable, right? Because I'm taking the sum by varying my I, and you would also know about sigma notations that whatever is not changing in your sigma notation is always a constant, and you can always take it out in order to simplify the expression. So let's do that. Since in all these cases, in all these three cases, my I is only changing, so I can take 8 by n out, I can take 16 by n out in this case, and I can take 8 by n cube out as well in this case. So let's do that. Remember, we are only doing this in order to simplify our whole expression and calculate the final answer. And if I do this process, I'm doing 8 by n, where I'm taking sigma I goes from 1 to n of 1. So I'm taking sigma I goes from 1 to n of 1. This becomes 16 by n. Sigma I goes from 1 to n again for I. And similarly, my third expression would become 8 by n cube. Sigma I goes from 1 to n of I square. And now it is the time to use the given information in the question. And we were given at the start in the question that we can use this fact that sigma for I goes from 1 to n of I is n times n plus 1 by 2, and for I square it's n times n plus 1 times 2n plus 1 by 6. So now we'll use these formulas in order to calculate the whole expression and get rid of our sigma notations. And we also know that sigma I goes from 1 to n for 1 would be n, because this is basically I'm taking 1 and taking the sum n times, right? So in this sigma notation, I'm basically taking the sum of 1 plus 1 plus 1 for n times. And this expression would then give me n at the end. So now based on the given information, let's calculate this out. So 8 by n times this sigma notation over here would become n, plus the second expression would become n plus 1 by 2, and the third expression would become n plus 1, 2n plus 1 by 6. And now in order to calculate the final answer, the only step that is remaining is to take limit n tending to infinity for my whole expression. And now since we have to take the limit of n tending to infinity of this expression, we can use the fact that it's easier to calculate the limit of n tending to infinity for the expressions in which we have n in the denominators, because we can use the fact that limit n tending to infinity for 1 by n is 0, 1 by n square is also 0, 1 by n cube is also 0, and so on. And we'll use these facts in order to calculate the limits. So now let's try to simplify this expression so that we can have maximum n's in the denominator. Okay, so now let's use this fact. But before we use that fact, I also realized one mistake. I'm sorry for that. We have 16 by n square. So we would have n square in the denominator in these cases. So this would be 16 by n square instead of 16 by n. I'm really sorry for that. So now let's finally modify this expression so that we can have maximum n's in the denominator. And we can clearly see that this n will get cancelled out, this n will be cancelled out with 1n, and this would cancel with 1n as well, and we would have n square in the denominator. And now I can simplify this expression and can write 8 plus 16 by 2 times n by 1 upon n plus 8 by 6 times n plus 1 by n and 2n plus 1 by n. And now after further simplifying it down, it would become 8 plus 8. N plus 1 by n can be changed to n by n plus 1 by n, right? 8 by 6 would become 4 by 3. This expression would again become n by n plus 1 by n, and this would become 2n by n plus 1 by n, which would finally become 8 plus 8 times 1 plus 1 by n plus 4 by 3 times 1 plus 1 by n, 2 plus 1 by n. And now we have to take the limit of n tending to infinity for this whole expression, right? And if I take the limit of n tending to infinity for the whole expression, I can split the limits in this case as well, right? I can take the individual limit of n tending to infinity for this expression, and for this expression, and can add them out, right? So now let's start doing that. This would become limit n tends to infinity for 8 plus limit n tends to infinity for 8 times 1 plus 1 by n, and this would be limit n tends to infinity for 4 by 3, 1 plus 1 by n, 2 plus 1 by n. And the rest process is pretty simple, right? Limit n tend to infinity for 8 is this. This limit would be 8 times 1 plus 0, right? And this limit would be 4 by 3 times 1 plus 0 times 2 plus 0, because limit n tends to infinity for 1 by n is 0. As n approaches infinity, 1 by n approaches 0, so that is why it's 0. So it would become 8 plus 8 times 1 plus 0. This would become 4 by 3 times 1 plus 0 times 2 plus 0. So now the final answer, which is also equal to the definite integral where my x varies from 2 to 4 of x square dx, and this would be equal to 8 plus 8 plus 4 by 3 times 2. So this is 16 plus 8 by 3, which would become 48 plus 8 by 3, and this is 56 by 3. And this is our final answer. And now by only using right-endpoint Riemann sums, we have evaluated the expression of a definite integral, and we got the final answer as 56 by 3. I know it's lengthy to calculate a definite integral like this, but this question is also a potential question for the midterms and final exams as well. So that is why it was also important to cover this question as well in this video series. So that's it for this video. I hope it made sense for what we did over here. In order to solve this question, feel free to comment down if you have any doubts related to this question or in general as well, and I'll reply to your comments as soon as possible. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye.